everyone. Welcome to another session of construction planning. So students, from past few lectures we are learning construction planning, and till now in the lecture series of construction planning we have started learning about network methods, and in the network methods we have learned about the definition of network, that the network is a flow diagram consisting of activities and events connected logically and sequentially. Then we have learned about what is activity and what is event. Any portion of the project which requires time and resource to complete, that is activity. Then we have seen types of activities, types of event. After that we have learned very important theory, which was rules for drawing the network. To draw the network we need to follow certain rules. Then we have started numericals for drawing the network. There were three subcategories of drawing the network: the data given in words or lines, data given in predecessor or successor table, and data given based on directly event numbers. And just in the previous session we have learned the concept of dummy activity. That dummy activity is a temporary or artificial activity, and it is there in the network to maintain the logic and to avoid the duplication of the activity. Clear? So that was done in the past session. So now today in this session we are going to learn, yes, we are going to start critical path method. So we are going to start with critical path method. Then we are going to see CPM application, CPM networks, deterministic approach, and then we are going to see start and finish time of activities. So today we are going to learn 5 topics. Yes, 5 topics. So starting with critical path method. So the critical path method was developed by DuPont and Sari Rand Corporation of the Germany for their industrial projects. But it was widely accepted by the construction industry, and it is most used method for the construction of building, railway, dams, bridge, etc. Yes, so the critical path method was invented by DuPont and Sari Rand Corporation. So now moving forward, let us see that by applying this critical path method in our construction we are able to find the answer of certain questions. What are they? Let us see. So here is use of CPM method provides meaningful answers of the following question. The first is, what will be the total duration of the project? Yes, by applying CPM method we can find out the total duration of a construction project. We can find that. How? We'll see that later on in the numerical section. Second question is, if there is delay in one activity, will the entire project will get delayed? If yes, by how much time? By applying CPM method on a construction project, we can see that, or we can give the answer that if any activity gets delay in the project, for an example, if concrete in foundation work gets delay, will it affect the project? Will the entire project be delayed? If yes, by how much time? So that can be done by CPM method. The next question, that is, what is the most economical method to complete the project? Being into construction, we are always in the crunch of budget. We always want to complete the project within the cost. So by using critical path method we can have the most economical way to speed up the project. That is known as critical path. So we'll able to find the critical path by applying CPM method. And the last question of which we can have the answer of, that is how to schedule the material deliveries so as to when materials are required, they are available, but avoid the excess storage of the material. Yes, the last question is coming to the material management point, that to have the material schedules, that as and when required, when there is a requirement of material, that so that we can have the availability of the material at that point of activity, but we need to avoid the excess storage of the material. So that is our fourth question, which we can answer by CPM method. So I hope we are clear about what is CPM method and what kind of questions we can answer by using CPM method. So moving forward, CPM networks generally used for the repetitive kind of project where you can have a fairly detailed estimate can be made for the completion of single activity, and the cost estimate can be made with the fair degree of accuracy. I am repeating it again. CPM method can be used for repetitive kind of project where you can estimate the duration for the performing an activity, and you can have the cost analysis very accurately for that. However, the CPM method, CPM networks or the critical path method is not used in research and development projects such as space projects. So the CPM method can be useful for the following projects: construction of multi-storied building, construction of bridges, and construction of new factories, etc. So CPM method you can apply when you can have the estimate of duration, that to perform a certain activity this much time will take place. If you can decide this kind of things, then you can go for CPM method. Now let us move ahead. So the next topic is CPM application. So the application of CPM is in three aspects: planning, scheduling, and controlling. Starting with the planning, planning is one of the most important phase of the project. In planning, you generally decide the sequence of the activities or what kind of activities you are going to perform in the project, and you are sequencing that one after another that activity will take place. Also, while planning, you must ensure that whatever activity you are representing in the network, that is of the scope of work, and you can allocate any time and resource to complete that activity. So that is CPM application in planning. The next is scheduling. In scheduling, the time required for each activity or the operation and the time order in which the activity will take place is decided. Here, scheduling is not only done in the aspect of activities, but in the aspect of the availability of resources. So when you are scheduling your project, you need to see that while you are performing that activity, for an example, if I am performing the activity from 15th February to 20th February, is my resources available for that period of time? If that resource is available, then and only then I could perform the activity. I not have to see that X activity is completed, then I can start Y activity. But to perform Y activity, if I have resources or not. So while doing the scheduling, I have to keep in mind certain things. And the last is controlling. See, in controlling, it is the process of having the deviations between plan and actual performance. That you have planned something and the actual performance is happening something. So if there is a delay or if there is a discrepancy between plan and actual performance, so that is known as a deviation, and you take control measures to recover that deviations in the project. Alright, so let us now look at what are the CPM networks. So CPM networks are generally activity oriented networks. While when we are going to learn the PERT, the program evaluation review technique, that PERT method is generally based on event oriented. So students, basically what networks we are learning, that are of two types, activity oriented and event oriented, and we are the CPM method is based on activity oriented. The activity is an operation which requires time and resource to complete, that you already know. The junction between the activities is known as arrow, and in the CPM network, activities are represented by arrows and the events are represented by circle, and network is a sequence of arrows involving number of activities. So that is our CPM network. There are two types of network, activity on arrow and activity on node. So the CPM method is completely based on activity on arrow, that you represent an activity by arrow. The other method is you represent activity by event. So that we'll discuss later on. So that is your CPM network. Moving forward, now let us talk about the deterministic approach. So the deterministic approach, that means it is assumed that enough information is available with you for each activity and single time estimate can be represented, that in that time the activity will be completed, and that single duration estimate is sufficient enough to give reasonably good result. So that is your deterministic approach. That in deterministic approach, it is assumed that you have enough data or enough information regarding the activity, and only single time estimate, that means that to perform a activity X days will be required. That is single time estimate, that you are deciding that to perform an activity X time or X days will require. So such data is such time estimate is enough to give good results. So that is your deterministic approach. Students, there are two kind of approach when you are deciding the duration of the activity. This one, deterministic approach, and second, probabilistic approach. So what happens in probabilistic approach, that you decide that what if everything goes right, the work can be completed as early as possible. Second, you can decide if something goes wrong and something goes right, the 50-50 time. And if everything goes wrong, late by late, how much time the activity will take. So that is probabilistic. But here we are talking about deterministic, that you know that to perform the excavation you will require 15 days, or to perform the excavation you will require 10 days. So that is deterministic, and that is why, now connecting it with the previous slide theory, it is used for repetitive. That when you have to do number of repetitive projects such as building project, then you are knowing that okay, to excavate this much area, this much time will be required. All right. So hence no uncertainties are taken into consideration. The duration of the activity is represented by Tij, where I is the predecessor event and J is the successor event. The duration of the activity is represented by Tij. All right. Now let us see the two event timings. The first is earliest event time, and later on we are going to learn latest event time. So what is earliest event time? The earliest event time or earliest occurrence time, that is earliest time by which an event can occur. In how much time an event as earliest can occur, that is your earliest event time, denoted by TE. It is the time by which all the activities discharging into an event under consideration are completed. The earliest event time can be calculated by adding up the duration of the leading activities of that event. For an example, if I want to calculate for the event, I need to see that how much activities are completed before the occurrence of that event. Alright, so I can have the TE. So that was the theory portion. Now let us see the graphical network representation of TE. Alright, so to have the understanding of TE, we are taking a network of one activity, only activity A, having I as predecessor event and J as successor event. Now students, here I would like to raise a point, or I would like to mention a thing, that as in cricket, when the first over is being bowled, but it is started with 0, 0.1, 2, and then the sixth ball is named as over number 1. So that is how in a project the first activity is started on the 0th day. So if I is the first event, then it will be have started at point 0. So for first event, earliest occurrence time will be 0 because that is the first. Let us represent that. So here is TEI. TEI equals to 0. But now I want to have the earliest time of event J, TEJ. So what I can do is I can add that TEI plus small Tij, that is my duration, small Tij. So that will be my TEJ, earliest event time for J. Let us see. Alright, so as discussed, TEI equals to 0 and then TEJ equals to TEI plus Tij. So that is my earliest event time. Now let us discuss latest event time. The latest event time or the latest allowable occurrence time is the largest time by which an event must occur to keep the project on schedule. That is known as latest event time, TL. But that was our theory portion. Let us understand that into our network representation. Alright, so that was up to TE, that TEJ equals to TEI plus TIJ. Now J was the last event of our network. That was only one activity, so that was last event. So what is TEJ? That is same as TLJ. So TEJ and TLJ will be the same. So that is our latest occurrence time, or latest allowable occurrence time for event J. Now I want to find for TEJ. So what I can do, to find TEJ, I was adding duration. To find TLI, I will deduct the duration. So TLI will be TLJ minus TIJ. Let us draw that. So here students, as you can see, TEI equals to 0. Now I have assumed the duration as 5. So 0 plus 5, 5, that is TEJ. Now TEJ equals to TLJ. So TLJ equals to 5. And again, to find TLI, 5 minus duration, 5 minus 5, again I'll come back to 0. But here the calculations are looking so simple because there was only one activity. When there are more than one activity, when there are number of activities coming out from event, where the number of activities merging in a single event, number of scenarios can happen, which we are going to discuss in our numerical section. So that was about event timings. Now let us discuss about activity timing, start activity and finish, start times and finish time of the activity. Let us see. So there are 4 kind of timings: earliest start time, earliest finish time, latest start time, latest finish time. So what is earliest start time? It is the time, or you can say in how much time as early you can start the activity, that time is known as earliest start time. By how much time? As soon as possible you can start the activity, as early as possible you can start the activity, that is your earliest start time. Second is earliest finish time, EFT. So it is the in what time, as early as possible you can complete the activity, that is earliest finish time. That in how much time, as early as possible you can complete that activity, that is your earliest finish time. The next is latest start time. It is the time by which by maximum you can start the activity. Late by late, in how much time, late by late you can start the activity. Latest finish time. So in how much time, late by late you can complete the activity, that is latest finish time. So EST, EFT, LST, LFT, and we are going to find all of them into our numerical of CPM method, which we are going to see in our next session. But that was theory portion. Now in actual network, or the example which we are seeing in the previous slide, how to find EST, EFT, LST, LFT in the network. Let us see. All right, so that was our example, that TEI equals to 0, TEJ equals to TEI plus TIJ, TLJ equals to TEJ, and TLI equals to TLJ minus TIJ. So TE is your EST, early start time. TEJ, that is your earliest finish time. TLJ, that is your latest finish time, and TLI, that is your latest start time. So EST, EFT, below that LFT, and that is that side LS. So I hope we are clear up to this point. From next session we are going to see the numericals of the CPM method. Now in numerical there could be three kind of questions asked in the numerical. First, find the total duration of the project. Second, find the critical path in the project. Third, find the floats in the network. The concept of float, that which we are going to learn in the next session. Alright, so in the next session we are going to see the numericals and we are going to see the concept of floats. So this is it. That was all about in today's session. We have learned 5 concepts of CPM method. That what is CPM method? That was invented by Dunpont and Sperry-Rand Corporation. It is activity oriented. It follows deterministic approach in which you are knowing enough information about the activity so that single time estimate can be represented. Then we have seen earliest event time, latest event time, and 4 activity durations, applications of CPM as well, and the questions of which we can find the answer by using CPM method. So in case of any query or doubt, you can always contact me on my mail or my number. Thank you.